Thanks for watching. If you enjoyed this video, please hit the subscribe button and ring the notification bell so you never miss an update. Leave a comment below to help grow the channel, and don't forget to smash the like button. Okay, in this essential math video, I'm going to derive the expression for the surface area of a sphere. So first let me fashion a sphere, not a spear. And so we'll make this sphere of, I'm going to consider another little slice up here. So what I'm interested in, this is the center of the sphere, and I'm going to consider little slices all the way up. So just imagine slicing this sphere as I've shown here, and I want to know, well, what is the radius of this little circle that I've drawn that is this cross section of the sphere? And so that's, if this radius is r, then this will be r. Let me just draw one more feature in here. This, of course, is r also. So, and here is the angle that we'll use for reference, theta. Doesn't look like a theta, but oh, now it looks even worse, huh? Theta. Then this is r cosine theta. So the radius of these little circles, these cross-section circles that I get when I slice this sphere, is r cosine theta. So I'm going to use that. So the circumference of this little slice, I'm just going to color it in so we can see it. The circumference of this little slice, of course, c for circumference as a function of theta, is equal to 2 pi times r, but we mean r cosine theta. That's going to be useful. Let's also remember the arc length formula, s equals r theta, such that ds, d theta, is just equal to r. This, of course, means that ds is equal to r d theta. That's going to be important as well. So now we're ready to start calculating the area. So the area, as a function of theta, is just going to be equal to the circumference as a function of theta times ds. Well, but I need the ds, so that's r, whoops, that's c as a function of theta times r d theta. So now I can integrate this. I'll just do the upper half of the sphere, such that this is going to be, the area is going to be equal to 2 times the integral from 0. Of course, our angle will go from 0 to pi over 2, because it's going to start out at 0 at the equator, and as it goes up to the pole, the angle theta will be pi over 2, so 0 to pi over 2, and of this area. So we'll have 2 pi, oh, I haven't even plugged this in yet, so I need to plug this part into here, so that'll be 2 pi r cosine theta, that's just the c, the circumference as a function of theta, times r d theta. Well, I already have an r, so I'll just square it, and that'll leave me with d theta over here. We're almost there. That's going to be equal to 4 pi r squared. Since we're not integrating, r is not dependent on theta, so I can pull that out, and I'm left with just 0 to pi over 2 of the cosine of theta, d theta. Now it's easy. So this area is equal to 4 pi r squared times the sine of theta evaluated between 0 and pi over 2, which is just equal to 4 pi r squared, because the sine of pi over 2 is 1, minus the 4 pi r squared times the sine of 0, which is 0. So the area, surface area of a sphere, is equal to 4 pi r squared, where r is the radius of the sphere.